Welcome, everyone. In this session, we will be discussing how to get started developing on AI glasses. Hi, I'm JungJik from Samsung. And today, my colleagues from Google and I are excited to show you how to start building augmented experiences for both AI glasses and display AI glasses on Android XR platform. As we saw in a keynote, AI glasses are the exciting new form factor coming to the Android XR family. AI glasses connect existing apps and users to the world around them with powerful audio and the conversation experiences. AI glasses with a display will offer users an innovative and accessible way to engage with your web, providing access and immediate interaction. With little to no additional development, we are extending several standard Android system services onto AI glasses. For example, Android XR brings media control, notification, and live update with the progress style into your user's line of sight. Users will be able to reply to chat messages without ever taking out their phone. That's what you get out of the box. But we know you want to create something truly unique and differentiated. To build bespoke experiences specifically designed for AI glasses, we are providing tools and API designed for this unique form factor. You are expanding Android XR SDK, enable developers to build for AI glasses. Early today, we announced the developer previously of Android XR SDK. To talk more about the developer previously of Android XR SDK, I will now hand it over to Tram.
Thanks, JungJik. Hello, everyone. I'm Tram, a developer relations engineer working on AI glasses. We are super excited to have you start building for augmented experiences on AI glasses with the Developer Preview 3. In addition to a lot of the new features and improvements for immersive experiences that powers devices like the Galaxy XR, we have strengthened the foundation of the Jetpack XR SDK and the Android XR emulator in Android Studio. We hope that this will help accelerate your development and enhance your productivity as you're building with a familiar suite of libraries and tools. While we are covering the Jetpack XR SDK and the emulator in this session, we know that AI is critical to the development of glasses. Therefore, to explore practical examples and learn about the Gemini API for integrating AI and contextual awareness into your glasses application, please tune into our talk, Leveraging AI for Apps and Experiences, where our colleagues Thomas, Kathleen, and Anthony will dive deeper into this topic. For the Jetpack XR SDK, we are introducing major updates tailored for building augmented experiences on AI glasses. The first of this update is the addition of 2 new Jetpack libraries focused on user experience and display. The Jetpack Projected library is built to bridge the gap between mobile and AI glasses with features that allow you to manage resources on your glasses. Jetpack Composed Glimmer is our new UI library designed for augmented XR experiences. Additionally, we are expanding AR Core for Jetpack XR to support AI glasses. This brings advanced perception capabilities to the glasses you wear all day. Next, I'll hand it over to my colleague Kabeer to talk about the AI glasses app model and dive deeper into the Jetpack Projected library.
Thank you, Tram. Hey, everyone. I'm Kabeer, an engineer on the XR team. And I'm here to tell you about the AI glasses app model. Developing for AI glasses requires your application to run on a companion host device, an Android phone which supports XR projected capabilities. Glasses apps are an extension of phone apps. Interactive audiovisual surfaces are projected onto AI glasses by simply adding new activity components alongside their mobile counterparts. As you can see, a glasses activity component is exactly the same as a phone activity component when declaring in the Android manifest file, besides an extra annotation that identifies these activities as projected activities. The activity itself will look very familiar to what you've already used to build interactive experiences on other Android form factors. The core distinction lies in utilizing the Glimmer Compose toolkit for AI glasses, ensuring a design that's optimized for AI glasses form factor. Activities on AI glasses, regardless of whether they have a display, are designed to operate with user awareness and active interaction. In this lifecycle diagram, you will notice the physical display on the glasses only affects the presentation mode, while the activity is in the resume state. Hence, your activity stays interactive even when the display is changing states between on and off. We have added presentation mode as a new signal as part of the Jetpack Projected library, which we will be talking about shortly. This app model ensures you can build consistent app experiences across different AI glasses. Access to glasses hardware, like cameras, microphones, and sensors, mirror access methods used on other Android devices. As you can see in the code sample, when accessing a camera within an activity projected on glasses, you call the same API as you would do on other Android form factors. Jetpack Projected supports the AI glasses app model and allows for the phone to seamlessly interact with AI glasses. Next, we will be introducing key concepts that allow for interacting with AI glasses. Launching an activity from a phone activity uses the same start activity method you're already familiar with the key difference being the activity options that you pass indicate this activity is meant for the projected display. Before launching an activity from the phone, you do want to check if the glasses device is connected. The isProjectedDeviceConnected method allows you to do so. In certain cases, you might want to check if the activity is running on a device that has a display or not, so you can optimize your app experience for that device type. For example, you may not want to download visual resources if the device does not have a display. This method, to get capabilities for visual UI, returns false for AI glasses and true for AI glasses with a display. On AI glasses with a display, the display can time out or the user can turn off the display. To design activities that run across when the display is on or off, we provide the following method that allows your activity to be notified when the display state changes. So you can tune your activity for the appropriate amount of audio information. AI glasses utilize a device-aware permission model to access glasses hardware such as camera. Our objective is to streamline these permission request mechanisms across both phone and glasses interface to provide a consistent permission request experience. As you can see in the code block, requesting permissions from the activity should feel familiar with using the projected permissions result contract instead of activity result contract. The permissions library makes it easy for you to let your user know clear rationale of why you want particular permissions. It handles the redirection to the phone and allows the user to grant permissions on the phone, making permission handling familiar and seamless. App Camera Actions allows for your activity to get access to user camera actions. For example, you may want to turn on and off your camera in your video streaming app. Your app can receive this user action and act accordingly. We have covered the fundamentals of building for AI glasses, focusing on aspects of development that will feel familiar, while highlighting where the Jetpack Projected library can specifically assist and enhance your development workflow. Now, I will hand it back over to Tram to talk about how to make your apps look beautiful using Jetpack, Compose, Glimmer.
Thanks, Kabeer. Now let's take a closer look at the Jetpack Compose Glimmer. Glimmer is our new UI design language and Compose UI toolkit for AI glasses. Jetpack Compose Glimmer is a demonstration of best design practices for beautiful display AI glasses experiences. It is the key to building user interfaces that feel native to the devices you're wearing all day. We've built Glimmer with 3 core principles in mind. First, familiarity. Because Glimmer is built entirely on Jetpack Compose, you can leverage everything you already know about declarative UI building in Android. We have provided a full set of core pre-built composable functions for you. For example, creating a button should look very familiar to you. Simply use the button composable provided by the Glimmer library. Buttons offer a clear visual feedback for their enabled, hovered, and pressed states to guide user actions. Another example is the card composable. Cards are highly adaptable, supporting a combination of main content, optional titles and subtitles, and leading or trailing icons. Next, we have the list composable. Glimmer lists are vertically scrollable UI components that efficiently render only visible items. This is designed to provide specific behaviors and input compatibility for Android XR glasses apps. Additionally, we are introducing specialized components like stacks. Stacks allow you to layer content effectively, letting the user focus on one important piece of information at a time. All of these Glimmer components and composables are instantly optimized for the glasses environment and require little to no developer lift from you. The second principle of Glimmer is glanceability and legibility. Unlike phones, the primary canvas for AI glasses is transparent. Glimmer provides glasses-specific theming, simplified color palettes, and typography to ensure your content is easy to read, fast to process, and never distracting. Finally, Glimmer supports glasses-specific interactions. We've optimized interaction models for how people use glasses. Glimmer components have clear focus states, like optimized outlines, and are built to handle common physical input like taps, swipes on the frame, and of course, voice. Jetpack Compose Glimmer allows you to deliver beautiful, minimal, and context-aware UIs right in the user's field of view. If you want to learn more about Glimmer, please tune into our talk, Design Best Practices for Display AI Glasses, where David, Adi, and Yasmin will dive deeper into this library. Okay, now that you know what it takes to create an app and make it beautiful, let's dive deeper into the Jetpack XR SDK. I'm going to walk you through how to implement the AR core for Jetpack XR APIs. This will help you access glasses perception data and enable your apps to understand and interact with the real world. With the Developer Preview 3, we have expanded the AR core for Jetpack XR library to support AI glasses with the motion tracking and the geospatial APIs. The motion tracking API allows you to track the glasses orientation in the world. This is foundation to enable experiences where your digital content can interact with the user's movements. For example, you can have content show up only when the user tilts their head downwards. Okay, to enable motion tracking, first configure your session by setting the head tracking mode to last known. This ensures the session tracks the device pose and leverages the last known pose from the system. Once your session is configured and running, getting the device pose is simple. You start by getting the device instance using the getInstance method and passing in the session. Because we've built this on familiar Android patterns, you can use the standard flow to collect its state in real time. The pose you get is the device pose, precise real-time orientation relative to the tracking origin. The device pose gives you rotation data, which defines the device orientation. Once you have the device pose, you can take your AR experience from a temporary session to a context-aware feature in the real world with the Geospatial API. The Geospatial API allows you to use real-world geographic information, combining GPS and our visual positioning system, also known as VPS. This high-accuracy localization can enable walking navigation, accurate location tracking, geofence triggers, and hyper-local information delivery. Similar to the motion tracking API, to enable geospatial features, configure your session by setting the geospatial mode to VPS and GPS, and the head tracking mode to last known. This tells the system to leverage visual data, GPS, and device tracking. Once configured successfully, you can grab the geospatial object using the getInstance method and passing in the session again. In areas with low GPS accuracy, like dense urban environments, this API relies on VPS coverage. You can check if a specific location has coverage asynchronously using the check VPS availability method and passing in a latitude and longitude. If the result returns VPS availability available, you're good to go. Now, let's talk about the core of the Geospatial API, converting poses. You can take the current device pose from a session and convert it to a geospatial pose using the create geospatial pose from pose method. If the conversion is successful, you can access the geospatial pose containing the latitude, longitude, and east, up, south criterion for the orientation. To go the other way and convert a geospatial pose to a device pose, simply call the create pose from geospatial pose method. This transforms a real-world coordinates into precise visual space for the glasses. So, through the motion tracking API and the Geospatial API, you can start creating AI glasses experiences with advanced perception capabilities, furthering delighting users with rich world-scale AR experiences. Next, I'll hand it over to my colleague Batool to walk you through a suite of developer tools to support glasses.
Thank you, Tram. Hey everyone, I'm Batool. I'm a designer on the Android developer team. And I'm here to tell you about the developer tools at your disposal starting today. Android Studio's tools give you everything you need to extend your apps for XR. That's why we've been working really hard to ensure that all of your existing Android tools are ready for your AI glasses development journey. Get started in Android Studio like you would for any other app on any other device using a simple starter template. This gets you immediately building using the beautiful Jetpack Compose Glimmer library. Create a glasses activity to start fresh or extend an existing mobile app onto glasses. We've done the work to hook up the libraries that you need right out of the gate. And to maintain the speed and iteration that you expect, we know you rely on Compose previews, and we've got you completely covered here as well. As of today, Compose previews in Android Studio officially supports AI glasses as its own dedicated device type. Instantly see your Jetpack Compose Glimmer UI update and render as you edit your code with one crucial difference. You can now swap out the background image. And this is not just a cosmetic change. Glasses use an additive transparent display, which means that they can only add light and they cannot create black. With the background images being offered by Compose previews, you can now instantly see how your UI performs against light, dark, as well as visually busy backgrounds. You're no longer guessing. You can see how your vital information is never lost in the real world, and you can design with certainty right inside the IDE. And now let's talk about debugging. We want to equip you with the AI Glasses emulator to ensure that you can test and run your UI with or without Glasses hardware. First off, we are working to make pairing a lot more simple and more intuitive. This dramatically speeds up your iteration cycles, allowing you to test everything from Glimmer UI logic to Gemini API calls based on voice and touch commands, all without leaving your desk. Within the emulator itself, we've prioritized the core interactions, giving you the ability to emulate the touchpad as it would be on the glasses itself, as well as voice input. And for the fine-tuning of your layouts, the Layout Inspector 2 is ready for AI Glasses development. With the Layout Inspector, you can compare your app layouts with your design mockups. You can examine details of your layout at runtime as well. So as you can see, we're giving you a full set of tools to get your Android apps ready for glasses today. And with that, I'm going to hand it back over to Tram to go over documentation and support.
Awesome. So with all of the opportunities for you to lean into building AI glasses, we want to ensure that you have the right support on your journey. As you're getting started, be sure to check out our design documentation, as well as our developer documentation. From there, you will be able to access guidance for developers and designers, as well as reference documentation for all of the APIs. When you're ready to jump in and work with code, you'll find that we have expanded the Android XR documentation to include AI glasses support. Since the augmented experience on AI glasses is an extension of the mobile app experience, AI glasses developers are also mobile developers. We have created a prototype branch in the existing AI catalog samples to support glasses. In the prototype sample, you can see implementation of the Gemini Live API, as well as examples of how to access the glasses hardware, such as microphone and camera. We've covered a lot today, but hopefully you are as excited as we are about the expansion of Android XR to AI glasses. To reiterate, you can start building AI glasses experiences today. Everything you need is available now in the Developer Preview 3. The libraries, the emulator, and all of the familiar tools and frameworks you already know and love as an Android developer. As you try these early tools and capabilities, we highly urge you to provide continuous feedback. We really do value your feedback, and it's how we improve the platform. Thank you for joining us on this journey. We can't wait to see what you'll build next.